A research team running competitive intelligence or market analysis workflows needs a system that can browse the web autonomously, synthesize findings from multiple sources into structured reports, run the language model locally to keep sensitive research private, store results in cloud infrastructure for team access, and monitor the agent's performance over time so the team knows when it is producing reliable output. Without these layers connected, the team runs manual research cycles. Someone browses, someone reads, someone writes a summary, and the findings sit in a document that nobody queries a month later. With a research agent platform built from these 5 repositories, a research question enters the system and emerges as a structured report with source citations, stored in cloud storage, and tracked in the team's performance dashboard. Browser use provides the web navigation layer. It is a library that enables AI agents to control a real browser, navigating to URLs, clicking elements, filling forms, and extracting ping page content, using natural language instructions. The research agent uses browser use to navigate to target websites, extract pricing data, find technical documentation, locate personnel information on company pages, and collect any structured data that requires JavaScript rendering or form interaction, rather than simple HTTP fetching. deepresearch provides the synthesis and report generation layer. It is a framework for running multi-step research workflows that iterate through source collection, fact extraction, contradiction resolution, and structured report generation. deepresearch takes the raw content collected by browser use and produces a coherent report with source attribution, key findings, and confidence ratings for claims that appear in only some sources. Ollama provides the local inference layer. All language model calls, browser navigation instructions, content extraction, synthesis, and report generation run through Ollama on the team's hardware. This means research content never leaves the team's infrastructure, which matters for competitive intelligence research, where the queries themselves reveal strategic priorities. The Google Cloud Node SDK provides cloud storage for research outputs. Completed reports are written to cloud storage for team access and archived with structured metadata, research topic, date, sources consulted, and agent run identifier, in Firestore for queryable retrieval. Grafana provides the monitoring layer. It tracks agent run duration, source count per report, Ollama inference latency, and report quality scores over time so the team can identify when research quality is degrading and which query types produce the most reliable outputs. Tracing a single competitive intelligence research task from question to archived report shows the data flow through all 5 repositories and explains why each component handles its stage exclusively. The task starts when a team member submits a research prompt through the platform interface. The research agent receives the prompt and decomposes it into a list of navigation targets, specific URLs, search queries to execute, and site categories to visit, using the Ollama language model. Browser use receives this navigation plan and opens a browser instance to execute it. As browser use navigates each target, it extracts page content and returns raw text to the agent. The interfaces between browser use and the rest of the platform are the navigation instruction format the library accepts and the extracted text blobs it returns after visiting each page. The agent accumulates the raw content from browser use into a source collection and passes it to deepresearch. deepresearch runs the synthesis workflow. It identifies claims across sources, resolves contradictions by weighting source recency and specificity, and generates the structured report using Ollama for each synthesis step. The deepresearch workflow calls Ollama multiple times, once for claim extraction per source, once for contradiction analysis, and once for final report generation. Each call stays local to the team's hardware. When deepresearch produces the completed report, the agent writes it to cloud storage using the Google Cloud Node SDK and creates a Firestore document with the report metadata, the original research prompt, the run timestamp, the list of sources visited, and the cloud storage URI of the report file. The Firestore write makes the report queryable by topic and date without requiring anyone to browse cloud storage directly. Grafana reads Ollama's built-in metrics endpoint and custom application metrics pushed from the agent, run duration, source count, and a simple length-based report quality proxy, and displays them on the research operations dashboard. When inference latency increases unexpectedly, the grafana alert fires so the team can investigate before a slow model degrades the next research run. The build order starts with ollama, since every other AI-dependent component in the stack calls it. Install ollama, pull the language model appropriate for the team's hardware, a 7 or 8 billion parameter model for workstations without a large GPU, a larger model if the hardware supports it, and verify that the API endpoint accepts inference requests by running a simple prompt from the command line. Measure the baseline latency for a prompt the length of a typical deep research synthesis call and record it as the grafana baseline metric before the agent is running. Configure the Google Cloud Node infrastructure next. Create the cloud storage bucket and Firestore database in the target project, and run a test that writes a small text file to cloud storage, reads it back, creates a Firestore document with metadata, and queries it by field. Confirm all operations complete with the correct data and permissions before connecting the application layer. Set up browser use. The deployment uses a Python or Node.js environment with a Playwright-compatible browser installed. Test browser use with 3 navigation tasks: extracting the main text from a product pricing page, filling a search form and extracting results, and navigating a multi-page documentation site and collecting headings. The interfaces between browser use and the agent are the navigation instruction format the library accepts, a structured action list or a natural language goal, and the text output it returns. Confirm both work correctly before connecting browser use to the deep research workflow. Security in this stack requires that research prompts and source content never be sent to an external API. All ollama inference happens locally, and this constraint must be enforced at the agent configuration level, so a future configuration change cannot accidentally route calls to a remote endpoint. Cloud storage bucket policies must restrict RID access to authenticated team members so research outputs are not publicly accessible. Failure handling in the browser use navigation stage applies a retree when a page load times out or returns an error status. After 2 retries, the agent marks the source as unavailable and continues with the remaining sources, recording the failed URL in the Firestore metadata. A fallback report is generated from the sources successfully collected rather than blocking the research run on an unreachable page. Deploy Grafana using its Docker container and configure the data sources, the ollama metrics endpoint and the application metrics endpoint from the agent. Deploy deepresearch as the synthesis orchestrator. The production deployment is complete when a test research prompt flows through browser use, deepresearch, cloud storage, and Firestore without manual steps. The documented configuration of each repository defines the research platform's coverage and privacy constraints. Browser use is MIT licensed. Its documentation covers the browser initialization with Playwright backend, the action type definitions for navigation, click form fill, and text extraction, the goal-based instruction format for natural language browser control, the screenshot capture for verifying navigation state, and the content extraction configuration for filtering irrelevant page elements. Deepresearch is MIT licensed. Its documentation covers the workflow configuration for multi-step research with source collection, claim extraction, and synthesis stages, the source weighting configuration for recency and specificity, the contradiction resolution logic, the output format for structured reports with source attribution, and the prompt templates for each synthesis step. The project notes that all LLM calls use the configured endpoint, making ollama substitution straightforward. Ollama is MIT licensed. Its documentation covers the model pull command, the API endpoint for chat and completion requests, the context length configuration, the GPU memory allocation settings, and the metrics endpoint for latency and throughput monitoring. The project notes that models run entirely locally and that no data is transmitted to external services. The Google Cloud Node SDK is Apache 2.0 licensed. Its documentation covers the credential configuration, the cloud storage upload and download API with resumable upload support for large files, the Firestore document read and write API, the query syntax for filtering documents by field, and the error handling for rate limit and transient server errors. Grafana is AGPL licensed. Its documentation covers the data source configuration for Prometheus-compatible metrics endpoints, the dashboard panel types for time series and stat displays, the alert rule format, and the notification channel configuration for routing alerts to team communication tools. The fastest path to a working research agent is installing Ollama and running one deepresearch synthesis task against manually downloaded source content. With a confirmed local synthesis, browser use can be added to collect sources automatically. Which competitor or market segment would your team want the agent to research first?